Okay, everybody. So we're going to talk what's called codominance. So codominance kind of refers to what happens if you have two traits that are dominant. And a great example is our blood groups. A, B, and O. Okay, so how does this work? So if you have A, type A could be, has a trait that expresses a protein on the surface. So here's a blood example of a red blood cell, and it's got these surface proteins, which we're going to say is kind of a pink or a reddish color. Okay, so we'll say that's type A. So type A has this red color, red surface protein. Okay, type B has a different one. Type B is kind of a yellow protein. So let's say type B. Okay, and then what if you have type O? So type O is a lack of a surface protein, so it just looks like this. So O is kind of like 0, if you will, okay? All right, so I'm sure you've heard also of another type of blood called AB blood type. So what AB is, what do you think? I showed 2 on here and 2 on here. What do you think AB would be? AB's got 2 of them, so it has both. It's got the red or pink and the yellow. So we call that AB. So AB has both. All right, so it works like this. You've got 3 different alleles. You've got an A allele, you've got a B allele, and you've got a O allele, which is a lack of one. All right, so if we took someone who is A and crossed them with someone with B, let me show that possibility here. So we have someone who's type A. We're going to cross them with type B. Now, of course, we don't know if this is right now homozygous or heterozygous and homozygous or heterozygous, okay? So we're not sure right now, okay? So let's just assume that they're homozygous though, okay? They're homozygous. I'm sorry. Let's assume that, let's start with homozygous. Yeah, it sounds like a good plan. So that would be like AA crossing with BB, all right? So that's AA crossing with BB. Okay? What do you get? Well, let's do it. A, B, B. Okay. You get AB across the board, right? All right. All right, so what if it's both heterozygous? Well, how does that change things? Okay, A, O, B, O. You don't want B, O. You don't want B, O. Okay, and so you get A, B, A, O, B, O, and O, O. You get 4 different blood types. Here's the question I have for you, though. How is AA different from AO? Are they different? How is the homozygous for A different than the heterozygous for A? Are they different? Okay, let's see. So we said A was red. So here is A. Now O was this. So what's the halfway between? Oh, well, it's that. Does it have the red surface protein? Yes. Yes, it does. So, does this have the red surface protein? Yes. But it has twice as many. That's the difference. Okay? Does this have the red surface protein? Yes. But it acts different from this one or this one because they only have this one. This one has both the red and the yellow, both A and B. This one only has A and A. This one has A and 0, nothing. Does that make sense? I hope. Okay.